Hello everyone. Now we will continue with the transient heat flow. So, we must have observed that when we wear clothing or we touch any object, we immediately feel either it's cold or it's warm. So, that the warm cool sensation it depends on the transient heat flow behavior of heat from our body. Okay. Maybe we receive heat or we may lose heat. Okay. But this warm cool feeling, it comes for immediate transient heat, it is a sensation of within a fraction of second. That's called transient heat. Suppose we are touching an object and immediately we may feel warm or cool, but after certain time it may fades away. So, that is how it is called warm cool sensation. Okay. Now, our human body is core temperature is kept it is normally it is 37 degree Celsius, and when the clothing we are wearing, it's normally its temperature is say less than the body temperature or its skin temperature, and it does not mean that we will feel cool of that. It depends on the various factors that these things we will discuss, and if heat flows from the body to the from skin to the clothing immediately, then we will feel cool feeling. So, the temperature fall sensed by the thermoreceptors, and higher the rate of the heat flow, more rapid the temperature will drop, and if the temperature drops rapidly, then we will feel cool. Otherwise, we may not feel cool if the temperature is actually its heat flow is at slower rate. So, the instantaneous heat flow rate, it is basically it gives the warm or coolness. So, if the heat flow instantaneous heat flow is there, then we feel cool because the temperature of our skin goes down. So, the rate of change in temperature resulting from flow of heat from skin to a clothing material at low temperature, the clothing material has to be at low temperature, otherwise we will receive heat. When brought into contact with it is determined by the thermal inertia of the material. So, if the thermal inertia is low, then we will not feel cool feeling. Okay. So, it is the material characteristics. There are many other characteristics. So, the thermal inertia is the function of density of the material, specific heat of the material, thermal conductivity of the material. So, all these things, if your thermal inertia is high, then we will feel cool. If the temperature the material's temperature is lower than the skin temperature. If the thermal inertia is not high, then we will not feel cooler. Like it is a thermal inertia is a function of density, specific heat and thermal conductivity of a material which is not conductive in nature. So, we will not feel cool. Like if we touch iron piece or some insulated wood. So, that is why that we know that it is a we feel cooler feeling when we touch iron, because of the it is a thermal inertia which is related to the thermal conductivity. Similar is the case of the clothing, and we will see that various factors which actually affect the thermal inertia. So, the density, specific heat and thermal conductivity of the material. So, any material that can absorb and conduct heat well is easily draw away the heat from the skin and we feel cooler. So, the higher the thermal inertia, the cooler is the feel of touch. So, feel of touch is extremely important because that material may not be cool. So, the one we can see the two material, one is the cool touch material if and another is the warm touch material. They are kept in the same environment, the effective temperature of these two materials are same, but the cool touch material gives the cool sensation, the warm touch material gives warm sensation because of the thermal inertia. And this thermal inertia, it is the material characteristics, that is if it is a textile material, it is a fiber polymer characteristics like specific heat, density, thermal conductivity, and the fabric structure also. In addition to this material characteristics, the polymer characteristics, the structure of material like structure of fabric, particularly surface property of fabric, have a great influence on warm cool feeling. One very classical example we can give, suppose if we touch one fabric made of say twill structure, say cotton cloth or twill cotton fabric, another fabric is made of cotton, the cotton satin fabric. So, if we touch the both the fabrics, we will feel the satin fabric gives better cool effect, cool touch effect than the twill, and this is due to the fabric structural feature. So, fabric structure, if the fabric structure is smooth, so satin, why satin gives higher cool effect, because satin has got high float length. So, large number of the areas contact area with the skin is more, that is why satin gives cool touch, and on the other hand twill as due to its projected structure, okay, that the contact area with the body it is less. So, it does not actually draw heat from our body at higher rate. So, we can control the warm and cool touch of fabric by controlling the surface structure of cloth. So, the bed sheet with our daily experience, we can feel that simple example of same two bed sheets are made, one is made of made from the same yarn, same say cotton yarn made of same ends per inch, peaks per inch, but one bed sheet is made of say plain weave, 1 by 1 plain weave, another is made of say satin. So, our experience says that it's a satin fabric gives a higher cool touch because of the higher contact area with the body, and they can draw that fabric can draw heat at higher rate, gives cool feeling. So, let us see this as the curve where the x axis gives a contact time and y axis gives the skin temperature. Okay. Now, this is the fabric, warm fabric, this is warm fabric, brushed fabric, the smooth fabric, and this one is cool fabric. Now, these two fabrics, the warm fabric means if we the sensation of coolness is estimated by measure of initial rate of change in temperature. So, initial rate of change in temperature. So, this is the temperature say at 95 degree Fahrenheit, and here it comes out to say 94.6 degree Fahrenheit. So, this rate of change initially it may be within say 2 seconds, 1 or 2 seconds. What is the rate of change in skin temperature? It is against skin temperature. So, that gives us the whether the fabric will be cool or warm. So, this is the for this is give the temperature does not change much, okay, skin temperature. So, this will give a warm feeling, and whereas this fabric, for this fabric it is a cool fabric, the temperature changes is very high. So, it gives warm feeling. Among these two, the smooth fabric and this is the smooth fabric and this one is the brushed fabric, they are made of the same material, same structural construction, but one is the normal smooth fabric, another is the same fabric is brushed. So, what is the difference? So, here one can see the smooth fabrics, the temperature drop is skin temperature drop is higher than the brushed fabric, because of the in smooth fabric the contact area is high. So, maximum rate of heat flow occur within 0.2 seconds after an object is touched, okay, and warm or coolness is related to the subject surface property. So, that if we change the surface, warm and coolness is that changes. So, now the question is that it takes away heat and the sensation of coolness is within 0.2 seconds, 0.2 to 0.3 seconds, but what happens the if we after that. So, after that it is not that it will keep on it will keep on drawing heat, because the environmental temperature is same. So, it cannot draw the heat it is at that rate, because it is a instantaneous heat change. That means, a fabric which is cool in touch, if we wear that fabric for certain time, say for 5 minutes 10 minutes, that cool sensation will go. So, that instantaneous cool sensation is within a second, okay. And after that what will happen, that same fabric may not be cool in touch, but if we keep moving, our body is normally it is not in stationary condition. So, if when our body moves, that means that same fabric will keep make different contact points, keep changing the contact point. So, every new contact point it will give again the cool sensation. So, when we keep on moving, the new contact point is generated and old contact point, earlier contact point is released. So, overall we will keep on feeling the cool sensation. So, now it is actually measured by maximum heat flux. So, which is observed shortly after the contact of the heated plate is correlated with the human skin. So, that how to measure this now heat flux. So, heated plate is kept. So, that heated plate is the temperature of heated plate is exactly kept in the around the 35 degree Celsius, which is human skin temperature, and when the fabric is touched with that, and immediate instantaneous heat flow, heat absorbed by the fabric is measured by the sensor. The instantaneous heat flow is measured. So, that is called the Q max. So, maximum heat flux is named as Q max. So, that is plotted against time. So, immediately what is the maximum heat flux, it is the heat is drawn from the plate, which is equivalent to skin, that is measured. Q max is taken as a measure of fabric thermal property in many instruments. So, Kawabata instruments which predicts the warm cool feeling, okay. And if we see, this is the diagram where the quantity of heat transmitted from the plate, heated plate, with respect to time, with reference to time is plotted. So, two fabrics are there, this is fabric 1 and this is fabric 2. So, fabric 1 is actually immediately it draws maximum heat, very high. So, this value it is a Q max. So, what does it show? This fabric which is actually summer clothing, which is actually taking maximum heat immediately from the body. So, that is why for summer clothing we have to use a fabric which has got higher Q max value. Similarly, for winter, if we use the same fabric, we may feel uncomfortable. So, to keep us comfortable, we have to use a fabric with lower Q max. So, transient heat flow should be as low as possible for warm clothing. So, we have seen that how to design then. So, for if we want to have a fabric from same type of same yarn, in that case we have to design a clothing for winter which will give us higher surface contact area, and if we have to design a clothing for winter, we have to have lower surface contact area. That you can reduce the lower surface contact area by brushing, by some other surface treatment. Okay. Now, this is an experiment carried out with different types of the fabrics made from different types of fiber, and at Q max value has been measured at different level of moisture. Okay. This is the Q max value for a particular for different fabric. So, Q max, it has been observed that Q max value increases with the increase in moisture level. So, what does it mean? Fabric, if fabric has got higher moisture, that means it will draw heat at higher rate from the skin. So, if it draws higher rate, the heat at higher rate from the skin, that means we will feel cooler. So, the Q max value increases with the increase in moisture content, which means that the fabric feels cool at higher moisture content. So, we will feel cool at higher moisture content, but among the fiber, if we see, this is the linen. Linen gives the linen which results a higher Q max value. That is why linen is called cool fabric. So, because linen has got higher Q max. On the other hand, if we see, the wool has got lower Q max value. So, wool, that is why wool gives the warmth. So, the warmth due for wool is due to two reasons. One is that wool has got the lower Q max value, and also wool, due to its specific morphological structure, that is it's basically it gives some crimpy structure. So, its contact area is less. So, lower contact area gives the lower that warm touch. So, that is we are not talking about here the thermal insulation, here we are talking about the warm and cool touch. Okay. And another aspect of wool is that wool, while absorbing moisture, when wool absorbs moisture, it releases heat, it is a exothermic absorption. So, that is again it is one of the reasons why wool is actually warm in even in the humid condition, it gives it releases heat. So, it is also clear that linen fabric has maximum Q max and wool has got minimum Q max up to certain level of moisture content. Okay. This is the reason why linen feels cool and wool feels warm when they are in there we touch them. Okay. That is why this is mainly due to the Q max value. So, higher correlation was observed between the physically measured Q max value and the fabric warm cool feeling by subjective assessment. Okay. There is a good correlation has been observed with the Q max value. So, that is why Qmax is the basically it is the indication of the warm cool filling. A high Qmax value corresponding to cool filling and low Qmax value warm filling. The value of Qmax depend on the fabric surface condition and not in the number of layers of fabric. So, if we even it is a single layer wool, thin single layer wool fabric will keep warm touch than multi-layer linen fabric. It is not the thermal transmission, it is the instantaneous transmission. Okay. The value of Qmax is sensitive to water content, okay, and surface geometry that we have discussed. So, rough surface gives warm cool and smooth surface give cool touch. So, that fabric which is warm, if we press through the calendar and then touch, it will give cool feeling. So, that is due to the surface contact area. And another way of releasing heat is it is a diffusion. Okay. So, the heat diffusion rate dominates when heat flows from source, that is skin to material, that is through heat diffusion, and it is depending on the area of contact, density of the material, thermal conductivity of the material, thermal diffusivity of the material and heat capacity. It is similar to that of Qmax, transient heat. When skin is in touch with an object different in temperature, the steady temperature distribution of the skin get disturbed, okay, and making the thermoreceptor of the skin to develop warm cool touch. So, that is basically this is mainly due to the diffusion of heat. Okay. So, we have discussed the steady state heat flow and transient heat flow. Now, we will discuss that how to measure this thermal transmission characteristics of clothing. So, it is very important to understand, measure the thermal characteristics, thermal transmission characteristics of clothing to evaluate that suitability of a particular fabric, okay, for a particular application. So, thermal transmission is measured by the one is the insulation value is measured by its thermal resistance. So, if we want to know the thermal insulation, so we have to measure the thermal resistance and which is reciprocal to the thermal conductivity. We can either measure the thermal resistance or we can measure the thermal resistance or we can measure the thermal conductivity. Okay. And thermal conductivity, which is watt per Kelvin, is measured by measuring the total heat transmitted. Okay. But total heat transmitted, it may be through conduction, convection, radiation through fabric per unit time with unit temperature difference. That is the way we can measure. So, we will discuss in detail. Conductivity is due to both fiber and entrapped air. So, that it is a combination of fiber and air, and fabric thermal conductivity we know this with this formula we can measure. And actually measuring the thermal transmission of through a material is it is very difficult, practical difficulties there. So, measuring airflow is very easy. So, we can take a channel, we can take a pipe and we can measure the quantity of air is flowing, any fluid flowing, like measurement of water flow through a pipe, quantity of water flow, it is very easy because we can measure the quantity of water flow per unit time, that is okay. But measurement of heat flow is very difficult because the heat flows in multiple directions. So, controlling heat flow in unidirectionally. So, suppose I have a fabric sample. So, if I want to know the conductivity of the fabric, so through this fabric the heat source is there. So, through heat, if we want that heat to be flown through only through this fabric, it is very difficult, because a source when heat is generated. So, it will transmit heat in multiple direction. Okay. So, that only directing the heat through the fabric is very difficult, okay. But directing any other fluid, air or liquid or any other fluid, it is very easy. So, that measurement it has got practical difficulties. So, this complication can be reduced by two methods. One is we can compare with the standard known material. So, if we know thermal insulation of any material, thermal resistance of any material, and if we place our test sample in series, then by comparison, by using the standard equation, standard formula, we can calculate the thermal resistance of the unknown fabric, unknown sample. So, that is a comparison with the standard sample, and this technique is known as it is used in the TOG meter, which is very popular in measurement of thermal resistance of fabric. And another is to reduce the heat loss to the other direction. So, if we can direct, if we can control the heat loss, then we can calculate directly. Suppose heat source is there, this is the heat source. Okay. Now, if we can control the heat flow only through this, only through the fabric, we can control, we can restrict the heat flow in other direction, then we can directly measure the heat flow rate per unit area per unit time. So, that these are the two approaches we can measure. So, first approach, by using the known sample, we can measure the characteristics of unknown sample, which is used in TOG meter, and by reducing the loss of heat in other directions, and this principle is used in guarded hot plate. So, these two principles we will discuss, and along with that we will discuss other techniques. So, this is the standard formula as we know. Now, TOG meter, there are two types of TOG meters are there. So, one is called double plate TOG meter, another is single plate TOG meter. So, it is a two plate, double plate, two plate stand. So, the method is the standard, and test sample have to be placed on in series. So, they have to be placed in series, and the internal resistance of the test fabric is calculated by comparing the temperature drop across the test fabric and the standard plate, okay, or standard fabric, we can whatever we can use, but here we normally use the plate, known plate. So, two types of TOG meters are there, one is two plate TOG meter, another is single plate TOG meter. In two plate TOG meter we use two plates, one is the standard plate of known thermal insulation, thermal resistance. Another plate here is that it is just to one insulating plate, just to cover that. So, this is the two plate, it is a top plate. Top plate is used just to actually control any external disturbance. Okay. In case it is a effect of air temperature is actually eliminated here, but the problem with this two plate top plate is that it has got its own mass, and the mass due to its mass, the fabric which is compressible in nature get compressed, and sometime it gives it is a wrong result. So, that is and this and fabrics with different compressibility will give different this thermal resistance value. So, that if we assume the compressibility of the fabrics are same, then it gives a better result, but if the compressibility of the fabrics are different, then it gives some wrong result. Okay. So, that is a limitation here, and here and the advantage is that here the problem of air disturbance is not there, and this is the bottom plate which is a standard plate here and with a known thermal resistance value, and our fabric sample, fabric specimen with for which we want to measure, know the thermal resistance here, and T1, T2, T3 are the temperature drop, temperature at across the this plate, this surfaces. So, this T2 minus T1 is the temperature drop across the known surface, known plate, and T3 minus T2 is the temperature drop across the fabric specimen. Now, the standard formula is that resistance of the fabric is actually by the temperature difference, it is basically it is a constant moment. So, resistance, actually the theory is that the resistance, if the materials are in series, then the resistance of one plate is proportional to the difference in the temperature. Okay. So, that means this is proportional to the resistance of fabric divided by the resistance of the temperature difference across the fabric. So, is constant. So, that means R fabric divided by T2 minus T3 is constant, equal to R standard divided by T1 minus T2, T1 minus T2 minus it will be T1 T2 minus T1. So, T1 minus T2 temperature difference is there. So, this T1 minus T2 is the temperature difference between the bottom plate. Okay. So, that is how it works, and we can get the thermal resistance value of the fabric by knowing the resistance of the bottom plate, knowing the T1, T2 and T3 value. So, this is the principle of two plate togmeter, and sample is placed between the heated lower plate and the insulated upper plate. This plate, upper plate is insulated plate. The upper plate should be as low as possible, the mass should be as low as possible, just to avoid any undue compression. These are the temperature at different point, and the heater, which is important, the heater is adjusted here at the bottom, there is a heater arrangement. The heater temperature is adjusted in such a way that the temperature T2, that is the temperature at the upper surface of the bottom plate, should be around the skin temperature. So, it should be around 35 degrees Celsius. That is how you have to measure the keep the temperature of the heater. Now, coming to the single plate togmeter. So, single plate togmeter, the problem of the compression, it is eliminated here. Here we use the single plate here, and the temperature in both side, other bottom side is the higher temperature is T1, and other side of the surface it is a T2, and the T3 which we take, it is not at the surface of the fabric, which is some distance above the fabric layer, that is it takes the ambient temperature. So, that means here the problem is that we have solved one problem by compression of compression, but we have added another complexity here. It is a where this temperature T2, it takes care of the insulation of fabric as well as the air. The air insulation is incorporated here. So, that we have to take care while calculating the insulation of the sample. So, the sample is placed on the heated bottom plate and the top plate is left uncovered. Okay. So, the air above the specimen has the considerable thermal resistance. So, initially in this technique, in this method, we measure the it is called bare plate test. We measure the thermal transmission of thermal resistance without the fabric, just to know the thermal resistance of the air. So, it is a bare plate test. The air above the specimen has a considerable thermal resistance. So, it is the sum up of the thermal resistance of the fabric. Okay. So, this total it will be air plus fabric. So, temperature T1, T2, T3. So, where T1 and T2 are the same as that of the two plate togmeter, and T3 is the temperature of air, which is room temperature. So, that T3 you have to ambient temperature. A separate experiment is therefore performed without the specimen, which is called bare plate test, to measure the resistance of the air, as we have mentioned. In case of base plate, it can be calculated, bare plate. So, it can be calculated that R air equal to similar way R standard multiplied by T2 minus T3 by T1 minus T2. So, what is this? This is actually the insulation of air when we are measuring the thermal insulation without any fabric sample. So, thermal resistance of air, and this is the standard plate. So, the experiment is again repeated after placing the fabric sample, and the apparatus is again allowed to reach to its equilibrium. So, that it is important that we have to allow the experiment up to the equilibrium point. Initially the temperature will keep on changing. So, after it reaches the equilibrium point, that means the heat flow is stabilized. So, after that only we have to measure take the reading of T1, T2, T3. Okay. So, the thermal resistance of the sample is we can measure. So, this is the thermal resistance of sample, this is the standard, and if you will take this value, and after that the earlier measured air resistance of air, we have to subtract from that. So, that we can get the total thermal resistance of the sample. Technique here in togmeter, it is used as that the comparing the thermal resistance of the fabric with the standard known sample, and these samples are kept in series. Okay. And next technique, as we have mentioned, it is a guarded hot plate. Guarded hot plate, it is in this technique we actually control the direct the heat flow direction through the fabric only, through the specimen, not, and we try to stop the heat flow from other direction. So, here in togmeter, another difference is that togmeter it measures the heat flow indirectly by comparing the, in togmeter we measure the thermal resistance, and which is indirect in nature, which gives an indication. But in guarded hot plate we measure the direct heat transmission. Here we do not measure the heat resistance, here we measure the heat transmission, the amount of heat transmitted through the fabric. So, which is actually reciprocal of thermal resistance. So, heat transmission is measured, which is reciprocal to the thermal resistance, and this apparatus it has got different sub components. First is that it is a test plate. Okay. Test plate is the plate where the actual heat transmission, the actual power drawn by the heat plate is measured, and above the heat plate the fabric specimen is placed. So, this is the actual the main the component of the this instrument through which the heat is transmitted through the fabric. And to restrict the heat flow from the test plate to other direction, sideway direction, the lateral heat flow is restricted by using the guard plate. It is covered with the, it is a basically typically it is a square in size shape. So, the guarded ring guard plate is actually placed around the this test plate to restrict the heat flow sideway, and another plate which is the bottom plate, it is called lower guard plate, which is placed below the test plate. So, and the temperature, the all these plates, test plate, guard plate and the bottom plate, their temperatures are kept exactly same. So, between say 33 to 36 degrees Celsius. So, at constant temperature is maintained. If it is 36 degrees Celsius, so 36 degrees Celsius will be maintained for all the plates. So, what does it mean? So, that if we maintain the same temperature, that means there is no temperature gradient. So, heat will not flow to that direction. So, heat will only flow to the direction of lower temperature. So, that is why this total system is placed at a temperature which is lower than that temperature. The standard is we can keep around say 4.5 to 20 degrees Celsius and around 20 to 80% relative humidity. This is the standard atmospheric condition where we want to keep the atmospheric temperature lower than the skin temperature, so that the heat flows through the that surface through the test plate and heat cannot flow in other direction. So, we will continue with this measurement techniques in the next class. Till then, goodbye, thank you.